Hello friends, welcome to Dr.RAjeshverma's YouTube channel. Pranam. In this particular video, we will be talking about standard deviation. This is a very important and the basic statistical technique that is used across the discipline, and I find that students find it little bit difficult to understand. But I'll let you know, I'll assure you, if you watch this video up to the last, certainly you are going to remember this standard deviation forever. This means you are never going to forget this, because I will going to explain you each nitty gritty of standard deviation. What does it mean? How it can be defined? What are its characteristics and how it can be calculated? So it's a very simple and very interesting statistical technique. Let us start with the meaning cum definition of the standard deviation. First, meaning. What standard and deviation means? Standard, as you know, there is a fix, some criteria based something, that is standard. That is standard of living. There is a standard of your income. That is standard of your style. So this way, there is a fixed criterion, and deviation means you are deviating from the norms. So this constitutes the standard deviation. It's a quantity. Let us talk about the standard deviation in terms of the statistics. It's a quantity that indicates by how much the members of a group differ from the mean value for the group. Means there is a mean. It's very important. Without mean, we cannot define standard deviation, we cannot calculate the standard deviation. So first step is the mean. So you must know how to calculate the mean. By watching this video, I presume that you know how to calculate the mean of group data as well as the ungrouped data. Now, so mean is the basic requirement to calculate the standard deviation and to understand the standard deviation. There's a mean, means suppose this is a mean. From this mean, your scores, there are scores are placed around that. These scores, how much they deviate, and in that case, that's the variability. The next step of variance is the standard deviation. Means how these scores differ from each other and from the mean value of the group. So this is the basic meaning of the standard deviation. And what is the definition? Guilford and Fruchter in 1976, they define standard deviation as an index of degree of dispersion and estimate of the variability in the population from which the sample is drawn. Means standard deviation is an index. What this index indicates? This index for the degree of dispersion and an estimate of the variability. These are the 2 points. So standard deviation indicates the degree of dispersion in a particular data, particular sample or particular population. Whereas, and it's an estimate of variability too. Means we can estimate how much variability exists in particular population or population of interest. So see, the standard deviation has 2 important components here. It's an index of degree of dispersion as well as an estimate of variability. So there is a curve, famous curve, NPC curve, we call it a known, that is a probability distribution. So this is curve. You must understand normal probability distribution, and along with that, what is the role of standard deviation in that. So when we discuss the characteristics of standard deviation, then we'll be discussing the role of NPC, normal probability distribution, that probability curve. So let us go for the introductory part. So one thing I'll let you know in between this video, the photos you are seeing here, the images, these are the images of 10 most famous Indian and prominent statisticians. So you must recognize them and see and understand and read their contribution in developing the statistics as far as the Indian contribution is concerned. Now, let us go for the introductory part of the standard deviation. SD, henceforth we'll be calling standard deviation as the SD. So SD is also known as the coefficient of variation because it represents, as the Guilford Fruchter has said, it represents an estimate of variability. So hence it is also known as the coefficient of variation. If someone asks you in a multiple choice question, what is the second name or how standard deviation can is also called as, so you must able to answer the question is that is coefficient of variation. It's a kind of special average of all the deviations from the group mean. So point you have to note here, it's a kind of special average. Special average means that standard deviation is beyond the simple arithmetic mean. Though it's a kind of average, but it is special average. Why it is special? Because it is the beyond the simple arithmetic mean. We'll let you know why it is known as special average. When we calculate the standard deviation for the group and group data, at that time I'll discuss and will describe you why it is known as special average. But it is an average. So you must know this. Along with the total range, semi-interquartile range, average deviation, it is the most commonly used single number to indicate the variability among a data sets. Means if you want to know the variability of a data set, then it's a very pertinent upon you to calculate the standard deviation. You want to know this variability of middle 50% data, then you need to go to semi-interquartile range. So variability is the scatter. What is the variability? No, it is scatter or spread of the separate scores around their central tendency. Means this is your central tendency. The spread of the scores around this central tendency is known as the variability. Means this is central tendency, this is your mean of the score, and you find the scores are placed at this location. The farther these scores are placed in the central tendency or the mean, higher the variability, and vice versa is also is true. As is the most computed using square stable index of variability, which is computed using square deviations that are taken from the mean only, because it is neither median nor mode. So you know, most stable index and most often calculated in technique, and it is calculated by squared deviation from the mean. So in standard deviation, you must know mean plays a central role, but there is no role of median and mode in the calculation or understanding the standard deviation or the SD. Now what are the characteristics of SD? These are various very important characteristics. If you understand these characteristics, if you could get the inside meaning of these characteristics, certainly I am sure you are not going to forget the concept of SD. First point, high value of SD. If you are calculating a standard deviation from a particular data given to you, if the value scored is little bit higher, how much higher I'll let you know later, but if you find this value high, it means that the most of the scores are away from the group mean and vice versa. Suppose this is a mean and the scores are placed this far, that shows that the variability, the variance will be going to be higher because the scores are placed at far away. At opposite side, if you calculate the standard deviation and it comes at to higher value, then you can clearly say, because the index of variability, that the variation or the variance is little bit higher in your data. Means your data is likely to be lesser homogeneous. Okay, this is the first characteristic. Second, it is the index of spread of scores about the mean that involves every observation. While calculating the standard deviation, it involves each and every observation twice. First, while calculating the mean. Second, while calculating the difference between, while calculating the deviation, that is difference between the each score and its group mean. So this is a very important characteristic. Standard deviation involves every observation. Now you may ask, can you tell me which statistical technique that doesn't involve every observation? You tell me. If you have seen my previous videos, this is a question I put into you. Very good answer. That is quartile deviation, semi-interquartile range. When the question, then the data set is in open-ended, that time that quartile deviation or semi-quartile range never considers the extreme values because it is calculated from the middle 50% of the data. So it's a very important point here. So standard deviation involves every observation or every score. Then the third characteristic, greater SD, standard deviation than mean. If the standard deviation is greater than mean, it indicates that distribution have majority of low values. Means the values are lower than what? Lower than mean. Getting my point? If the standard deviation is higher, and vice versa is also true. If the value of standard deviation is lower than the mean, this indicates that the distribution have majority of high values. High values of in which context? What is the reference point for the values? So that is the mean. Means if the standard deviation is, the value of the standard deviation is lower than the value of the mean, in that case we can safely say that majority of the values are higher than the mean in your distribution. So it's a very important characteristic because you know this index. So whenever you calculate a standard deviation, it indicates various properties of the, you can call as a distribution. Then the next characteristics, it can also indicate, important point, just remember, just listen carefully, that whether the distribution has dispersion of the extreme values or a standard tendency. Because if you calculate standard deviation, it gives a very important indication that whether the distribution, whether your score set, data set has a dispersion of extreme values or it has some central tendency. So these are very, very important characteristics as I told you earlier. So if you understand each characteristics in its totality, certainly you are going to understand the standard deviation completely and you are not going to forget that. So my dear friends or my dear colleagues, who are those watching this video, the focus, kindly concentrate on understanding these concepts, these characteristics. Next, it is expressed in the same units as the data has been expressed. So there is no separate unit mentioned for the standard deviation. So if the data is in meters, standard deviation will be in the meters. If the data is in the centimeters, data in the liters, or data in the any measuring unit in decibels, certainly standard deviation will be having the same units as the data. This is a very beautiful characteristic of the standard deviation. Next comes the, it is possible to calculate the combined standard deviation of two or more groups. If you calculate the mean, you have to calculate the mean of each group separately. But standard deviation can be calculated for several groups together. Means there is a combined standard deviation calculated for the various set data sets. Next characteristics. The standard deviation is considered most appropriate statistical tool for comparing the variability of two or more groups. So I told you that standard deviation indicates the variability, dispersion, or the central tendency, or the several indicators. This is very important tool here, that is when you are going to compare the variability, variance of two or more groups, that time standard deviation comes very much handy. It explains and it compares the difference or the similarity of the variance among two or more groups. So dear friends, I am constantly telling you, requesting you to understand these characteristics to understand the standard deviation. Next comes, it is used as a unit of measurement in normal probability distribution. So here comes the my point. I told you when I was discussing previous slide that I will discussing the NPC and its connection with the, or its association with the standard deviation. So if you want to know what are the units, suppose there is one particular question comes in your examination, what is the units of normal probability curve, NPC? You know the units? So unit of weight is kilogram, unit of, you know, sound, decibel. Similarly, what is the unit of NPC? Can you tell me? Yes, that is standard deviation, SD. SD is the very, very important and the only unit of measurement of the NPC, normal probability distribution. So this is a very, very important point. How it is. You see, this is a normal NPC normal probability curve. Here, this one indicates what? One standard deviation. Two indicates what? That is here. It is two standard deviation. Three is also three standard deviation. And towards this side, towards the left side of the zero, minus one means minus one standard deviation, minus two standard deviation, minus three standard deviation. What does it indicate? Means if your score falls between plus minus one standard deviation, then you can say the 60% of data falls here. So this is very, very important point, that SD is the unit of measurement of NPC, normal probability curve or normal probability distribution. So these are 9 characteristics and one more characteristic, that is 10th. Standard deviation forms the base for several statistical techniques such as skewness, kurtosis or ANOVA. Or ANOVA, you know, it's a very basic analysis of variance technique, and this basic techniques purely depends upon the standard deviation. Later comes the multivariate data analysis. Various ANCOVA, MANOVA, MANCO and everything, they all based on the standard deviation. So it's a very, very important, you call it it's a base for the statistics. Though SD itself depends on something else, that is mean. So my dear friends, these are the 10 characteristics. If you understand these characteristics in letter and spirit, and if you know how to apply them, certainly you are not going to forget the SD, because SD will going to permanently embed in long-term memory. Now let us move for the, there is one question students generally ask, sir, how much SD is good or bad? The student who are going to dive deep in the statistics, or those who want to study statistics or make career in the statistics, certainly they are going to ask this such question. How much SD can be considered as a good or bad? My dear friends, remember, no amount of standard deviation is either good or bad, because it's just an indicator of spread of scores. If your SD is 100, I cannot say it's a good or bad. It only indicates the variability or spread in your distribution. If someone is now, who then in this case, who decides that this SD is good for me or this SD is bad for my data? Suppose if someone or some researcher is interested to see the closeness of the score around the mean, in that case, if SD should be less than or equal to 1. Getting my point? If you are interested to see the closeness of your data around the mean, in that case, your SD should not go beyond 1. Whereas if someone is interested to see the larger spread, how means if my data has to be have high variability, in that case my SD should be greater than or equal to 1. So this is not a fixed criteria. This is a crude explanation. And one more thing, certainly this is not going to be a scientific term, but this is very important. It's a reference point to understand the quality or goodness or badness of SD. But across books and manuals, it has been accepted that SD greater than or 1 is the indicator of high variance or variation among the scores, and if SD is less than or equal to 1, it indicates low variation or low variance among the scores. It's a kind of rule of thumb. It's a kind of crude indicator. It's not scientific one. It's not applicable across the globe or across the situation, but it's a crude indicator. It's a rough indicator. Roughly you can estimate. Getting my point? Again, I'm telling it's a rough indicator. In fact, SD, standard deviation, depends upon the data set and the objectives of the researcher, what researcher wants to conclude, what researcher wants to study, or how he wants or she wants to be explain his or her data. So that purely depends upon the data set as well as the sample size as well as the objectives of the researcher. So there is a no definite answer of the question you put up to me, that is how much SD is good or bad, because it's an indicator and it depends upon various factors. Next, how to compute the standard deviation. This much time we have discussed the meaning, definition, goodness or badness and characteristics and all introductory part. By this time, if you watch this my video from the starting to up to the point, I am sure you could get me and you could understand the meaning and the basic concept of this standard deviation. So if you calculate the standard deviation, how to calculate that? And there are two types of data. One is a group data, one is ungrouped data. So let us start with the ungrouped data, and we'll take a hypothetical data. This data is purely my imagination. It doesn't associate with any type of practical observation. This has been whatever come to my mind, I've written there. And so this is an hypothetical data. So never take it as guaranteed. How to calculate the standard deviation of the ungrouped data? I told you. Before proceeding, I told you SD is dependent upon one concept, that is mean. So if it depends upon the mean, certainly we are going to in the first step calculate the mean. You know what is how to calculate the mean? Certainly I suppose and I believe that you know that. But if you do not know, still I have mentioned the formula here, summation x by n, where is x is the scores, whereas n is the total number of scores. So in that case, in our ungrouped data, the summation x is means if you add all these scores, the answer will be 374, and you know these scores are total number 11 scores. If you divide 374 by 11, the answer will be 34. My dear friends, this is 34 is the mean, first step in the calculation of standard deviation. Mean is represented by x bar, so x bar is 34. Next step, step 2 for the calculation of the SD. What is that? You to calculate the deviations. You know what is deviation? Deviation is a very technical word, but it is a very simple one. If you subtract your mean from each score as shown in the table. So this is your x, 12 is an x. You know what is your mean? 34. 12 minus 34 is minus 22. That is your deviation. So you have to calculate this deviation for each score individually, independently. Then you'll be getting two types of deviations. One is minus deviation, other one is the plus. So if you total these the whole deviation, your answer should be 0. If your answer is 0 in that case, this means you are proceeding correctly. There is no mistake in the calculation. But if answer is 0, then how to calculate? Then there is a one more step here. Square each deviation. Suppose this is a 22 minus 22. If you score it, it has to be 484. Certainly minus sign will go away. The square of 20 is the 400. 2, 4, 17, 29. This way you have to square each deviation. And finally, what to do is add all these square deviations. That is summation d square. That answer will be 2327. First step, calculate mean. Then second one, calculate deviation, means subtracting the mean from each score, and then squaring these deviations, and then adding these deviations, and finally substitute your values in this formula. Summation d square divided by n whole under root. So our answer will be 14.545. My dear friends, I'll let you know here two, three important points here. I told you when I was discussing the introductory part of the standard deviation, special average. Here comes the point. There is average. It is the average of squared deviations. And from that you have to calculate the square root. So this is this special average, means you are squaring each deviation, adding this deviation and dividing that deviation by number of deviations. So it's a kind of special average. Now one point, students generally ask me, sir, why we calculate the square root? My dear friends, you know, you squared the deviations and then you add that, because to make up for that square deviation, and why you square? Because you have to make up for the minus sign. You have to remove the minus sign. For that you have to go for the squaring of the deviations. Once you square the deviation, certainly your answer will be in the squared form. To the antidote square is the square root. So you have to calculate the square root. Getting my point? So this is the logic and reasoning behind why we calculate the square root of the that deviations. Because in fact in previous step you squared the deviation. So this is a very simple one. So my SD is a little bit very high. It is 14.545. It indicates that there is a large variation in my scores. You can very well see that my lowest score is 12 and the highest score is say 58. So this is a large spread in my scores data set. So this is a simple way to calculate the standard deviation as far as ungrouped data is concerned. So next point is the standard deviation of group data. I find various students find it little bit difficult to calculate SD of the grouped data. My dear friends, if you know how to calculate the mean of the group data, certainly you are going to know, and it's very easy for you to calculate the mean of the standard deviation of the group data. Here there are various methods, short methods and long methods, because I expect that before the first time students who are watching this video, they must know the long method. Shortcut method, methods you can devise later, you can learn later, but the first you must know the each step of the calculation of the standard deviation, that is algorithm. If you understand each step or algorithm of the group standard deviation, certainly you are never forget the, but shortcut methods you can learn later and through your own intellectual ability also. But the first point is you must know the each step. The first step is calculate the mean of the standard, that is group data. For calculation of mean, we must follow the following few steps. There are certain steps that is devised for the calculation of the mean. So here is again it's hypothetical data in this table. First, these are the class intervals we have devised. These are the frequencies. Getting my point? So you will get this much data in your question answer. That is question paper. From that you have to calculate the standard deviation. How to calculate that? You know this much. First you do is, first your job is to sum up your frequencies. Add up your frequency and find out the total number of frequencies. In our case it is 50. Step 2. See, not step 2, the steps of calculating of the mean. How to calculate the mean first? Find the midpoint of each class interval. So very important step that we designate as a x. How to calculate the midpoint? Suppose the midpoint of 5, add these both class intervals. 5 plus 9 is 14, divided by 2 it is 7, 10 plus 14 is 24, divided by 2 12. These are the class intervals, and if you calculate first or two class intervals, then you will say you will find a difference, a common difference between these, because there is a size of class interval is 5. So every time your midpoint will keep increasing. The C 7, then 5 at 12, 17, 22, 27, 32, 37, 42, 47, 52, 57. So you need to calculate every midpoint. Calculate 1 or 2 and keep adding the size of class interval. You will reach calculate each midpoint. This short method. Then second step. So I am discussing the calculation of the mean. First you know how to calculate the mean. Second, multiply your midpoints with the frequency, respective frequency. Suppose you're 57, 57 into 1, 57, 52 into 3, 156, 47 and multiplied by 3, again it is 141, 42 multiplied by 5 is 210, 37 into 10, 370. This is multiplying your midpoint with its respective frequency. Getting my point? So this next, add up these fx, the product of midpoint and the frequency, add all these. So this way we will be getting 1650. Simplest technique. After that, divide it by number of frequencies. Summation fx, this is a formula, divided by n. Summation fx is 1650 and divide by 50, because 50 is your sum of your frequencies. So that will be your mean will be 33. Getting my point? These are the simple steps to calculate the mean of the group data. There are other methods, assumed in methods. I am not going to discuss that. You can read yourself and you can apply that formula. There is a shortcut method, but this is simplest method, and this is a very reliable method of calculating the mean. Though it will take a little more time, but first time you have to understand and use this method only, my dear friends. Next, so we'll be calculating this SD now. As mean is the base of the SD. Now we will calculate the mean. The next step is the simplest one. Calculate the what? Deviations. How to calculate deviation? Deviation means each subtract your mean from the each score. Here each score is your midpoint. As I told you, x up to this column. Now this is x. What is x? Is 57 minus your mean. What is your mean? Can you tell me? Your mean was 33. So 57 minus 33 is a 24. 52 minus 33 is a 19. This way, my dear friend, you will keep calculating x minus x bar. Getting my point? These are the deviations. And we'll denote this deviation as a x minus x bar. After that, you to square these deviations as you've done in the ungrouped data. in the case of ungroup data. So suppose this is the square of 24 is 576, 19, 361. This way you to square each deviation. Again, I am reminding you why we square, to remove the minus sign. That values will indicate by x dash. And in the next step, multiply x dash with the respective frequencies. You may be getting confused right now, but my dear friends, if you keep watching this video up to end, I'm sure you're going to understand the concept and the calculation method of the standard deviation. So in this step, multiply the x dash with the respective frequency. Here x dash is 576 multiplied by 1, 576. X dash is 361 multiplied by 3, it is 1083. X dash is 196 multiplied by 3 is 588. Your x dash is 1 because square of 1 is 1 multiplied by 10 is equal to 10. 25 multiplied by 8, 200. This way you are going to calculate the product of f and x dash, and in the last step add these fx, add these squared deviations. So our answer will be 5512. So standard summation fx dash is equal to 5512, and after that put up in the formula. Formula is equivalent to the mean because it's specific average. So divide this summation fx product, the sum of the product of frequency and x dash, that is 5512, by the total of the frequencies, that is 5512 divided by 50, you will 110.24, and if you square root it, your answer will be 10.499. One more thing, before calculating square root, that answer comes, that is also known as the variance. And you know, standard deviation is the square root of variance. So my dear friends, this is the standard deviation of the group data. I quickly revise that. First, to calculate the mean. For mean, calculate the midpoints, multiply the midpoints with the frequency, add up that total and divide by your total number of frequencies. That will be your mean. The next step, subtract your mean from each midpoint, and that midpoint will be, and square that midpoint. Your answer will be 5. That will be your x dash, and finally multiply your x dash with your each respective frequency and add all these, and that will be your summation of the total product of the frequency and the x dash. X dash is the square deviation. So that will be divided, if you divide by the number of frequencies, that will be your answer, will be your variance, and if you calculate the square root of that variance, that will be standard deviation. See, one more point I have to add here, dear friends, in various videos, various books, you will find that someone is dividing by n minus 1. Division is the n minus 1. So if you divide your product, sum of the product of the frequency in the x dash, that is square deviations, by the total n, that will be SD of the population. But if you want to calculate the standard deviation of the sample, that time you have to reduce 1 from the total of frequencies. If you want to calculate the SD of the sample, in that case you have to divide here instead of 50, 49. So these are the nitty-gritty of the deeper statistics you are going to learn when you are going to apply and you are going for the next higher courses. In that you can understand it. But what I discussed in this video are the basics of the standard deviation. So my dear friends, if you have any answer, you want to know any question, any query, you can write my comment box. You can email me at varmasujit@yahoo.com, and these are my references. You must read these 2 books, important books, Guilford, J.P. Gilbert book and Garrett book, for the understanding basic concepts of the standard deviation more deeply. So in the end, my humble request, if you like this video, share with your friends. If you say something, you want to say something to me, write in my comment box, or you can email me at varmasujit@yahoo.com, and our next discussion will be the concept of normality. So we are going to the next BA final year semester 1 and unit 1, that is the concept of normality. By the time, thank you friend for watching this video.